This is the presentation of machine learning course project. Our project name is Sohu Low Quality News Recognizing. Our group members are Zhang Tianhao, Fan Yongyong, Hong Shaoxin, and Zheng Weihou. With the continuous development of information technology, thousands of information recommendation methods have brought convenience to millions of netizens. However, at the same time, low-quality news such as marketing, vulgarity, and clickbait have also brought different degrees of troubles to users. Machine learning is a field of computer science which utilizes statistical techniques to give computer systems the ability to learn with the data without being explicitly programmed. The objective of our project is to provide users with a better reading experience. To achieve a better result, we did some experiments by using fast text, support vector machine, logistics regression, and convolution neural network. Each of these algorithms has its own advantages and shortcomings. And we want to try our best to achieve a good result that can provide a high quality reading. After the introduction and the background of our project, the first thing we need to do is the data pre-processing, which is the most fundamental step for model training and the machine learning. When we collect data from Sohu News website, the original data is not clear, which means it contains a lot of HTML tags and useless characters. What we need to do in the data pre-processing step is using some technologies to remove tags and stop words at first, and do the word segmentation by using some framework such as JBA, Thalek, and TLP, and so on. And the final step in the data pre-processing is do the word embedding. Let's move to the first part, data cleaning. As you see, the original news data contains some text, which is the noise for our machine learning model. In the first step, we remove HTML tags by using some regular expression. The result after this step will move to the second step. At this step, we use a stop words dictionary to remove some numbers and non-ASCII characters such as comma, brackets, and so on. As mentioned before, there are many word segmentation frameworks, and we chose Thalek, a simple Chinese analyzer, to segment sentence into words in our project. For word embedding, there are two state-of-art techniques to achieve this. One is GROW, proposed by Stanford NLP group, and the other is the famous word-to-vector presented by Thomas McAuliffe while he was in Google. We can use word-to-vector model to train word vectors with the help of JSON, or alternatively. For saving time, just use a pre-trained word vectors generated from a large amount of Chinese corpus. To load the pre-trained word vectors, we simply run the following code. After data pre-processing, we can apply classification algorithms on the dataset. There are three algorithms we choose to do the classification. First, SVM. This is a workflow of our word count based future model. The detail will be introduced after next several slides. The model can be roughly split into three parts: feature engineering, generate feature counts, and the model's training. After the observation of the data, low-quality news are found to have some regular patterns. Most directly, some words may frequently appear in some kinds of news. For example, the word champion often appears in advertisements. So in future extraction, we firstly count words based on low-quality news and sort them by frequency in descending order. Then we do handcraft future engineering by picking up those words which are most likely to cause the news to be low quality. We call them future words. These are some of the words picked up and their corresponding frequency. The next step is to go through all the news and do the counting based on those future words. Finally, we get the counts of future words for every news, and this will be the future for classification. The picture are words counts for some news and their corresponding labels. Based on the future words count generated in future extraction, we can train our classifiers. Here we tried 3 different algorithms as our classifiers: the SVM, neural network, and the logistics regression. Unfortunately, these algorithms did not perform very well with a public score of about 0.5 on the online validation dataset. FastText is an open source, free lightweight library that allows users to learn text representations and text classifiers. It is a simple shadow neural network with only one hidden layer based on continuous backlog words model. It can achieve a baseline performance very much faster than other deep models. This is a code demonstrates how we train, validate, and predict with FastText. From the experiment results, we can conclude that FastText can achieve an accuracy of 67% on local validation dataset and 60% on online dataset. Next, we want to introduce 2 deep learning models to do the text classification. One is CNN, which is the short for Conclusion Neural Network. Another is LSTM, which stands for Long Short-Term Memory. This is the architecture for CNN. This is the architecture for LSTM. Here is the code shows how to load word vectors with JSON and how to construct an embedding matrix with Keras. Here is the code shows how to build CNN and LSTM on Keras. Next, I will make a conclusion on our project. From our experiment, we can conclude that FastText, which is based on CBOW model, simply a small shadow neural network can actually achieve a baseline performance very much faster than other deep models. Traditional machine learning algorithms did not perform very well due to the lack of semantic understanding. CNN can achieve a state-of-art performance not only in image recognition but also on text classification. LSTM usually performs very well on NLP tasks. However, in this task, it only achieves an average performance while taking the longest time for training. And this is all. Thank you.